Hello students, we're back again. This is lesson 23B. Yesterday we did this little program about pirates' first name and last name and reading files. So today I just have some comments to discuss the loops. That's the main thrust of chapter 5. The first one I want to talk about is the do-while loop. It always executes at least once. Now you should be typing these notes in so you can study them for exams. That's the whole idea. If we were in class, you would be, face to face, you would be typing along as I talked. All right, so integer a equals 1. So we're declaring a variable here. We are saying we have an integer a and our variable's a, and we're going to initialize it at 1. And we have another variable, integer b, and we're initializing it at 1. Then notice we have two do-while loops. That means they're nested. This one is inside of this outside one. So the way the nested loop works, you initialize, you do your first outside loop once, and then you go inside and you finish this loop. Then you go out and do another iteration of the outside loop, and then you do the inside loop again, and then the outside loop. And notice each time that we finish the inside loop, we reset b to 1, because this will count up to when b will eventually be 4 and make this false. That would end our loop. So to keep it, going again for the next round, we reset b to 1. This is outside of this do-while loop. Here's the beginning, here's the ending of the internal do-while loop. So this is done in the outside loop, okay? So if we were to run this, the output would look something like this. So everything's initialized at 1. So right now, do while a is 1, because notice this is a, so we know we're going to do this at least once because we're using do while. So it'll come down and it'll say, well, a is 1 and b is 1. It started out 1, 1. We look 1, 1. Okay, then we add 1 to b and we go back up, print out a, which is still 1, and b, which is a 2. Then we add 1 to b. We go back around, print A, it's still a 1, B is a 3, and then we add 1 to B, now B is a 4. Oh no, this is no longer true. So it goes out here and it adds 1 to A, and it sets B back to 1, okay? So now we go back to our internal loop. A is 2 now because we added 1 to A. So now A is 2, here's our 2, and then we print that 2, and then we print B, which is 1, because we reset it to 1. So we got 2, 1. We add 1 to B, so we go around, we print A again, which is a 2, and then we had added 1 to B, so now it's 2, so we have 2, 2. Do this internal loop again. It becomes 2, 3. So you can see how this will complete, and it goes out and does the outside loop, and then the inside loop completes and does the outside loop. Okay? The inside loop is creating the ones place, and the outside loop creates the numbers in the tens place in this situation. Okay? Let's do some more nested loops. For loop example. For, and now we're going to declare a variable a and initialize it as an integer and equal to 1. If a is less than or equal to 2, if it's true, the loop continues until it's false, and then we add 1 each time. But on the internal loop, integer b equals 2, so we start a variable b, set it as an integer, and we set it to 2 to start. B is greater than or equal to 1, so the loop continues as long as that's true, and then we're subtracting 1 every time we go through the loop. So notice here, first time to the loop, A is 1, B is 2. Then we do this internal loop again. So A is still 1 and B is 1 because we subtracted 1 here. And now we subtract another, B is 0, so this is no longer true. So we go to the outside loop, and now we're going to add 1 to A, so it becomes 2. And it goes back down to this. So now B is 2 again. So we got 2, 2, and then it does the loop. We subtract 1, and this is still 2, but B is now 1, 2, 1. Okay? All right, let's start with modulus discussion. Explaining the modulus operator. 2 divided by 2 is 1 with a remainder of 0. So if we did 2 modulus 2, we would just get the remainder for the answer, not the actual answer to the division problem. But what is the remainder? 3 divided by 2 is a non-zero. It's a non-zero, okay? Modulus will return the remainder from a division operation. Is 7 a prime number? How can you tell? Well, you start dividing from 2 all the way through 6, all the way up. We know 1 and 7 will divide it evenly, so we just do from 2 up to the number below, or minus 1, the 7, okay? So 7 modulus 2 is a non-zero. It will have a remainder for the answer, for the division. If I divide 2 into 7, it'll go 3 times, and then with a 1 for a remainder. Will 3 go into 7? It'll go twice with 1 for a remainder. Will 4 go into 7? It'll go once, but it has remainders, etc. So all these will be non-zero. If they're all non-zero, the number is prime. Okay? If they're all non-zero. All right. Let's look at another while loop just to give you an example of how while loops work. Integer a equals 2, b equals 3. While a is less than or equal to 4, that's our external loop, the outside loop. And then while b is less than or equal to 7, that's our internal loop. Okay, so b starts out at 3 and a starts out at 2. So if b divided by a is 0, well, b starts out as 3. 3 divided by 2 is not going to be 0, so else we'll get AB. So here in our output we get 2, 3. Then we add 1 to B. So now it'll be 2, 4. So is 4 divided by 2 going to have a 0 remainder? Yes. So it would say 2, 4, found 1. So here we go, 2, 4, found 1. And then if we add 1 to B at the end of this loop, so we go back, now B is going to be 5. So 5 modulus A, which is still a 2, can I divide 5 by 2 evenly and get no remainder? No. So it's going to print 25. Okay? And then we add 1 to B, and now B is 6. So 6 divided by 2, is that a 0? Yes. So it says found 1. It prints this one out. And then now we add 1 to B, goes back around the loop. Now B is 7. 7 modulus A, 7 divided by 2, is there a remainder? Yes. So this is not true. So it just prints out 2, 7. And that's what we have in our output here. Okay? All right, so that's the end of Lesson 23B. I hope it's helpful. I hope it prepares you for the exam. I'll be talking to you again soon.